do today is talk through our concept, Topcon's concept of continuous representation of reality. But I want to start off just by mentioning something that last week I visited an event called Autodesk University out in Las Vegas. Autodesk University, Autodesk were a strategic partner of Topcon, and we were out there with 10,000 others. It's their annual global user and partner event, and full of innovators and full of innovation, new products, new solutions, new workflows. And we were there showing some of our BIM integrations, primarily with construction and layout, construction layout, and machine control integrations. So showing all our latest stuff. And I mentioned this because I want to really... So I mentioned this because all about innovation. And I wanted to introduce you to Topcon. Some of you probably, not sure how many are aware of us. But I wanted to introduce ourselves through some of the innovations that you may not be aware of. From back in the 1950s, Topcon were the first to patent the SLR camera principle, through to first robotic total stations, first imaging total stations, and the first to come up with 3D machine control solutions. Also, that's our positioning company. On our eye care division, which you're probably not aware of, we have a number of innovations in optics and in eye measurement. Something else you probably don't know is that if you look at those Google Street View and Microsoft mapping, web mapping solutions, that a lot of the initial kit that you see on the vehicles on some of those images are actually Topcon gear. So a real innovation company. One of the most recent ones that was launched last week was with a new partnership between Topcon and a company called Dacry. You may have heard of Dacry. They develop augmented reality solutions. And you'll see one of their products there, a smart helmet on my head. And we are working with them on integrating some of our positioning technology into their wearable technology, specifically for construction. So exciting times coming there. So what I wanted to talk about is really this concept of CRR, what we call CRR, which is continuous representation of reality. And this is really, I guess, it's the vision for the industries that we're serving. And what it really means is bringing all our technologies together to really create an immediate, true model of the environment as we see it. So it means combining our mass data capture solutions with telematics, with GNSS, and making use of some of the web solutions we have, cloud-based solutions, and the mobile technologies. So bringing all that together to make all that data accessible through the cloud and through mobile technology. So our mass data capture solutions can all be combined together with other measurement technology to create this CRR. And outside on the booth, please come and visit us. We're showing a lot of these technologies. So some of those technologies, including aerial mapping, for instance, we can see there our fixed wing UAV, through to mobile mapping, which I'm going to be talking more of a bit later. So this is where the kit sits on top of a vehicle, whether it be a car, a boat, or whatever, combined with terrestrial laser scanning, and our more recent UAV, a rotary wing UAV. So it's all capturing mass data that we can all bring together to make available for consummation throughout the BIM process. So increased accessibility to all these solutions leads to increased application areas. So not just for survey, for visualization, but for some of the areas that we're really seeing a lot of interest in at the moment. So, for instance, daily construction site progress for 4D scheduling. So sending a drone up every day to see where we're at in terms of a construction site project, through to data capture primarily for asset management. So aerial mapping. So we've got 2 UAVs, or drones, if you prefer to call them that. The fixed wing, the rotary wing. The Sirius Pro for larger area coverage, which is the fixed wing. We haven't got that here today. We've got the rotary wing. So highly accurate aerial mapping. You can define flight plans, heights, and very robust in all weathers. You can define your flight path, as I say. It's got RTK on board, real-time kinematics, and it's got GPS accuracy. And then we have the rotary wing, the octocopter, that you can see outside. Please come and have a look at that. That's quite new. Named a Trinity. We call it the Trinity because it's got 3 levels of safety through redundancy. So very, very safe solution. Mainly for inspection, monitoring, closer up work in hazardous environments. Very robust, safe, easy to use. Can come with different payloads, so depending on what you want to do with that, both for inspection, survey, and it's got a handy cam as well. And then we've got terrestrial scanning, again combining depending on what you want to capture and the detail that you want to capture. So we've got our laser scanner, really robust, easy to use laser scanner, comes with ScanMaster software for short, medium, long term, up to 500 meter coverage. And then mobile mapping. So mobile mapping is the kit, so it's combining both cameras, 360 camera technology, with laser scanning. Very simple to use and very safe, because basically this can go on a vehicle. So if you're wanting to capture highways, rail, etc., then you can put it on a vehicle and drive at normal speeds, and it will capture the surrounding information. High precision, we can get point clouds and images from mobile mapping solutions. So big advantages there, both in terms of speed, cost, safety, completeness. So use once and use many times. Collect once and use many times. So the application areas for mobile mapping, we're really seeing big use in terms of asset management. So capturing for maintenance purposes, also for topographic mapping, survey, and geo-enabled applications. So for asset inventory, for instance, so taking and using our own and partner software, such as Autodesk software and Orbit, to grab information, for instance, driving along a road and taking information on, say, lighting, traffic signage, road damage, power lines. So anything that's close to the street, taking that information and adding metadata to it. And then topographic mapping, so creating and updating object-oriented maps, which are both GIS enabled, and also we can plug those in and integrate into CAD workflows, CAD BIM workflows using Autodesk tools, using tools like InfraWorks and Navisworks that you may know of. Also solutions such as LFM and Varimetris, object recognition, so including feature recognition to automatically index some of that reality captured. So for instance, with traffic signage, road markings, railway tracks, clearances, etc. So a good example of this was with Belfer Beatty on some of the M25 projects we did, where we had a Navisworks portal, which allowed you to, based on the chainage of the road, so as you drive along the road in the 3D model, it recognizes information automatically from a kind of dashboard of information. For survey, for construction especially, and mines and quarries, so basically analysing volumes and capturing design versus as-built, the ability to create grids and meshes using both ScanMaster and magnet solutions that come from Topcon. So all these solutions can create 3D point clouds using various software, whether it be from Topcon or Autodesk, and giving you a full 3D experience, both from the images that are captured, the 360 images, you can see some of them there, and you can get inside those bubble views and see the point clouds, and it's giving you the routes and the full trajectory information at real refined detail. Plus it's also giving you the GPS positioning information as well. There's some examples here that have been captured. So this one is for asset information for Dublin City. So this was a mobile mapping application where the City of Dublin wanted to build an asset inventory. This data was captured with a week of survey work, and it captured the complete street furniture and set up a database that the local government is using. Another example here, which was all about mapping land use, object-orientated maps. This was in the Netherlands, and it was really building up a 3D relational database of thematic information. So basically mapping 30 sites in only 3 weeks to get all that information, gather that information, and then being able to query land usage based on that. Another example here in the US this time, again with mobile mapping on top of a vehicle, was all about managing assets of electricity poles. So analysing locations, really for maintenance issues more than anything. So looking at pole location, so this had feature recognition built into it as well. So looking at maintenance of poles, where those poles were being used for other utilities, and looking at clearance, sag, vegetation encroachment, etc. Another city example here, this was in Istanbul. Different kind of commercial application. So again, mobile mapping, capturing city information from a vehicle. But this was all about area and view analysis, really, for calculating rent and value from advertising space. So looking at where advertising hoardings were positioned, what the views were, so the city council could come up with calculation of the rent that they could charge for those advertisers. And project mapping a city centre, this was in fact an example, was Rotterdam. And this was really done to test, as a test case, really to show that you didn't need to have control set up, control points set up. So we ran a number of vehicles over the same route, and then to match those, you can see in that image there, you've got some of those poles where you can see a double image. So we took that through software, registered cloud to cloud to get one refined image. So it was really to prove the point that you didn't have to have control set up, which would have caused major problems. And the final example we've got is, again, it's about CRR, and it's about bringing different technologies together. This one was all about Tower Bridge, and again, looking at dredging and accessibility and access to below the bridge. But it's also using an echo sounder data to combine that information with it and take that into one 3D representation. So it's not only giving you the context, but it's giving information below and above the bridge to show where dredging, to show clearances really in the channel. so for boats to pass under. So it's giving us all that information that's needed to make those dredging decisions. So a few examples there. As I say, we're outside on the booth. Please come and talk to us. We've got most of those solutions outside. If you want any more information on some of those examples, we're here to ask. So thank you very much.